So let's begin by taking a look at what that interface might be like to be able to transfer money from one account to another in a system we're designing in 1972. Anyone have a thought? What you might look? You don't have much to work with, folks. First of all, there's no mouse, so your life gets a lot easier without a mouse. What's it going to be? Go ahead. Probably some way to put in an account number. Maybe we'll call it from account. ACCOUNT. All right. 2 account numbers. From and the to account. The to account. All right, and what else? An amount. Yeah, that's pretty much the minimum we could get by with. So let's come in here and, I don't know, put a thick border around it. Thick outside border for that one so we can see it. Home, thick outside border. Thick outside border. Great. Well, this is kind of what it looks like. And this is really what they looked like. There wasn't that much to them. Should we have a submit button? No, there's no buttons. There's no mouse. You got to press enter. We wore the enter key out on these keyboards. We had it all the time. And in fact, these screens would get burned in because there were only like 4 or 5 different screens that they spent most of their time on. And so even when the screen was off, you could still tell what the main menu was on these computers. Really good. Okay, so now let's imagine you're the teller filling this in. Someone walks up and says, I want to, transfer some money. I'm going to come in here, going to type in the account number, say it's 1, 2, 3, 4, 5, 6. And that's my savings account, and we're going to transfer $10 to my checking account. 2, 3, 4, 5, 6, 7. All right, let's identify what the risks are. What's the problem here? Is it flipped? 2, 3, 4, 5, 6, 7. Oh, yeah. I don't know. I'm transferring it from one to the other. I don't care. Maybe it's a transfer my checking to the savings. I don't know. So, yeah, okay, that's one problem. You might put the 2 accounts in the wrong order. Okay, we're going to have to train the users to do that right. Oh, did I? Oh, that's what you're talking about. Oh, it's because the way we designed this in the last class, the amount was in the middle. That's what you were saying. Sorry. And I lost my border, for crying out loud. Okay, what are the risks besides putting an account for an amount? Whoever owned account 10 in that situation was going to be pretty happy. Actually, there wouldn't have been that much money to transfer. What's the problem? What's the big risk? Look at this from a risk assessment. What's the problem with doing this? Yep. Yeah, someone's going to type an account number incorrectly. They're going to transfer money out of their savings account to someone else's checking account. That would be a problem. So, it's 1972. How are we going to solve that problem? Got to have some way to make sure that doesn't, happen too often. What are we going to do? Any thoughts? Go ahead. Okay, so what you're suggesting is that, maybe you have a special kind of account that says I'm transferring money from one of my accounts to another one of my accounts. I mean, the bank's going to let me transfer money from my account to anyone's account I want to. If I'm taking it out of my account, that's fine, I'll send it anywhere. But you might say, yeah, we want to make sure it goes, you said you're doing a single person account, we'll make sure that it goes to that same account. No good in the 1970s. And the reason is because that would require me to check, another round trip to the server and check to see if that's a valid account number. To see if that's an account number that this person has. And it's too expensive in terms of how long it takes to request that, as well as how long it takes to process that request on the backside. We've really got to trim this down to bare essentials. And so it's a great idea for today. No way we could have done it in the 70s. We'll go here, here, and then here. Go ahead. Okay, so again, we could front side, so it's not going to be too processor intensive or involve too much time in data transmission. It would probably work, and that works okay, except if the error in the keying of the number isn't on the output, but it's on the input, if I read it wrong. I'll type it in the same way both times. And so that's going to reduce some of the errors, but it's not going to reduce them all. We're going to see if we can come up with something else. There was someone over here. That was the same idea? Same idea? Yep. Okay, yeah, so we're going to check to make sure that they've got the amount. We've got to check that. So, yeah, you can't transfer more than you've got. So, but we're trying to deal with this question of mistyping a number. None of these solutions were the one that we came up with in the 1970s, by the way. Go ahead. You're tentative. So type it in twice. Or even have two different people type it in twice. Problem is, come to this line, go through this line, now go to that line to do the other half of it. That's not going to work either. And so, no, let's take a look at what we came up with. Here's the idea. It turns out that we want to do this with as little overhead as possible and still be reasonably sure that we've corrected, for the kinds of mistakes that people would make. So, we've got 6 digits. That's going to get us almost 1 million different account numbers. But here's what we're going to do. Instead of leaving this as 6 digits, I'm going to make it 8 digits. I'm going to put 2 more digits on it. These last 2 digits don't have anything to do with identifying the account. These last 2 digits are what we refer to as a checksum. So this is now the account number is not 6 digits, the account number is now 8 digits. So when I ask for your account number, you're going to supply these 8 numbers. The user is going to type them in, and the computer then is going to look and say, does the sum of the first 6 digits equal the last 2 digits? And so if I make a mistake, any single character being typed in correctly, anywhere in here, that can no longer be the case. And so this is referred to as a checksum, and we can calculate it very quickly. And it takes almost no processing power, and there's almost no overhead. I don't even have to type the whole number twice. It's just 2 more numbers on each one that I can do. And it guarantees to prevent any single mistake from getting through. What do you think?
One of the most common mistakes is just switching 2 numbers. Doing the 3-word switch.
In fact, you're right. So switching any 2 numbers, well, it's not true. I mean, if I switched these 2 numbers, that'd be a problem. Or if I switched these 2 numbers, but you're right, anywhere in here, any of these that are transposed, it's going to come up with the same algorithm. Folks, it was 1970. Disco was popular. And so, we hadn't come that far in life. This is our first step. But you're right, they realized pretty soon this doesn't catch the most common error, which is the transposition of 2 sequential numbers. And so we'd really like to be able to catch that as well. And so the process evolved from just a simple checksum to what we refer to as a check digit. It's called a check digit because the gold standard was this. We wanted to reduce the overhead down to a single character, 1 digit that we could type in. That would guarantee that any single number typed in correctly would yield an invalid account number, and any 2 numbers transposed side by side would also guarantee that we wouldn't have accidentally hit a valid account number. And so you realize the checksum is extraordinarily simple. And we came up with other algorithms that were more sophisticated, but still they're just math. Computers can calculate it like that. And we were able to come up with different ideas. So that's what we're going to do today, is we're going to see how to implement a check digit in a number that you guys are all very, very familiar with. It's your Temple recommend number. There's a check digit, and I'm just kidding. It's the ISBN number. We'll take a look at that. Is there a check digit in the Temple recommend? There probably is a check digit in the Temple recommend number. I'll have to look next time I see one of the books and see if they're sequential. They probably aren't. Okay. But before we do that, little historical note of interest. Full credit for class participation if you can tell me who Frank Abagnale Jr. was. Oh, see? Some of you are getting ready to Google, and then like a bunch of you know it. Go, you're who I saw first. It was probably because of the vocalization that accompanied the... Okay, so he's a guy who in a movie was portrayed by Leonardo DiCaprio. You're partway there.
Okay, well, let me finish.
Yeah.
But he was a con artist.
Okay, he's a con artist, yeah. And in fact, he was financial. He conned financial institutions, airlines and financial institutions were his main targets. Turns out he was the first one to figure out that you could really delay how long it took for a check to clear. if you had routing numbers on the bottom that sent it to the wrong region to be cleared, like it would take weeks and weeks for anyone ever realized that you had written a bad check. That was the fraud he did the most with. But his very first fraud dealt with this system that we're looking at here. Have you ever been to the bank and needed to make a deposit, but you didn't have any of your deposit slips? That ever happened? Do you ever go to the bank and make a deposit anymore? It's been a long time since I made a deposit, personally. You don't have a deposit slip. What are you going to do? Well, there's a counter right there where you're waiting in line. They got a whole stack of them right there. They're called counter deposit slips. You fill it out, and the place where your account number goes is blank. You fill in your account number, you fill in your information, you make your deposit. Well, Frank noticed that a lot of times people didn't fill in their account number when they were making their deposit. What does the teller do if there's no account number? What do you think? It's 1972. What do? You're the teller. Edna has just come up and she's making her, her monthly deposit. Edna, you don't have your account number. What are you going to do? You're going to look it up. Oh, I know, Edna. We'll look it up. Here it is, your account number. We'll type it in. But what if Edna put her account number on? Do you look it up to make sure it's right? No, you just type it in. You deposit the money. So Frank took a stack of these back to his house, rolled them in his typewriter, and typed in his account number. And then took them back to the bank and put them on the counter. So now Edna comes in, she takes the thing, and she writes out her information just like she does all the time. She takes it up, the teller looks at it, keys in the account number, deposits it, and they're off. A week later, he withdrew several thousands of dollars, closed the account, and walked away. That was his very first fraud against a financial institution. What does that have to do with what we're talking about here? Nothing, just I like to talk about my fellow former faculty members. You know he was on the faculty at BYU? He claims to have been. BYU denies it, but anyway. There we go. I think I just put that on record. That's recording. That's no secret. Okay. So let's take a look. On today's schedule, I have posted an Excel document which should give you the algorithm for calculating the 10-digit ISBN check digit. Oh, 10-digit. Turns out there's two kinds of ISBNs. Full credit for class participation if you can produce a book that has a 10-digit ISBN. It's been quite some time since they switched to the 13-digit, but still many books are printed with both the 10 and the 13-digit. The book identifier is the same. The only difference is they added 3 digits on the front, so instead of just being a book number, it becomes a product number, and that different. And there's a different algorithm, and so the check digit is the same. The check digit is different. So if you have a 10 and a 13-digit ISBN, you'll see the middle part are exactly the same because it's the same identifier. You got one? Oh, it's the Stice brothers. Oh, there we go. Yeah. There's the two. So it's got the top one is a 10-digit ISBN, and the next one is the 13-digit ISBN. You can't quite see the 13-digit check number, but that's the 10's the one. May I borrow this for class today? Full credit. Okay. Make sure you record it. All right. Man, intermediate accounting. So let's take a look. So here's how we calculate it. It turns out this is a well-formed ISBN 10-digit check digit. 1, 2, 3, 4, 5, 6, 7, 8, 9, that's the identifier. And then the last digit is the check digit. In the 10-digit algorithm, there are 11 possible check digits, 0 through 9 and X. It's kind of unfortunate that there's an X because it means you can't type this thing in from a 10 keypad. In fact, for people that work in the book industry, like if you go to the bookstore, if you look at the computers they have on that they're checking out books with, chances are they've got a special keyboard that has an X somewhere over there next to the 10 keypad. So you could type in these numbers from the 10 keypad. So here's how I calculate it. I take the first number, and somehow these numbers got a little bit off, but I take the first number, I multiply it by 10. Second number, which is 2, multiply it by 9. Third number, multiply it by 8, and so forth. So this seems a little strange because this one just counts right up. It's not necessarily always counting by 1 because this is coming from the algorithm here. So let me make a copy of this sheet. Just copy it. And let me put in the Stice brothers number here. So it is 0, 0, 5, 3, 8, 4, 7, 9, 7, 3, 6. And so this is calculating that last digit, so you can see here that it has calculated that 6 as the last digit. So this is a well-formed ISBN. So we take the first digit, multiply it by 10, the second digit, multiply it by 9, the third digit, multiply it by 8, and so on. We sum those up, 247. We then take 247 mod 11. Oh, mod 11. Full credit for class participation. If you can explain to me, you just got full credit. Back off, partner. If you can explain to me the modulus operator. Go ahead. In the back, yep. Yeah, remember back in 4th grade when you're learning long division, you take some number, you divide it by some other number, and you get, you like go and you carry down, and then you do some other things, and ultimately you end up like remainder 3. So that remainder is the answer to modulus. So if I'm just doing integer division, then the quotient is the answer. If I'm doing modulus, the remainder is the answer. So this is the remainder when I take 247 divided by 11. The remainder is 5. I then take 11 minus 5, and that's my check digit, unless it happens to be 10. If it's 10, then the check digit is 6. So in this case, it's not 10, so 6 is going to be our check digit. Why X, for crying out loud? I got to say 10 with one character. Why do I choose X? You can use 0. 0 is okay. So there's 11 possible characters, 0 through 9, that's 10, and one more that I've got to figure out. So I heard it over here. It's how you say 10 in Roman numerals. It's one character that says 10. It's just not, the normal 10. It's Roman numerals. And so, yeah, that's where it's from. Okay, so this is our task today, is to be able to implement this algorithm in VBA. Could we do this in a single formula in Excel? We could. It would be ugly. So we're going to write it in VBA. It'll still be pretty ugly, but at least when we go to use it inside the workbook, it'll look nice, because we'll just create a function called isValidISBN, and we'll be able to call it right from here inside this workbook. I'm not going to build it in this one. I'm going to build it in a brand new blank workbook, just so that we're not confused by thinking that sheet has something to do with our calculations. So I'll open up a new window and insert a module. Somehow I've lost my immediate window, and I've also lost my formatting here. Fiddlesticks. Let me go ahead and readjust here. Options, editor format, 12. Let's go a little bit larger, say 18. Did I not change that? Tools, options, editor format, 18, and OK. Tools, options, editor format, the size is 18. Am I clicking OK here? That says OK, doesn't it? That's a little bit disconcerting. You might have to move closer to the front to see it if you can't see it in the back. Sorry about that. Insert module. All right. Thank you, Microsoft. In the back, can you see this okay? Can you read that? You're okay? All right, good. All right, so far, we've made all of our code inside what we've called a sub-procedure. Open up a module, put sub, end sub, and we work inside that with a macro. Today, we're going to make another kind of procedure. The procedure is called a function procedure. It's exactly the same as a sub-procedure, except when the function procedure is done running, it sends a value back to wherever it was called from. Let's take a look at how it works. I say function, and then I give it a name, just like I would a sub-procedure. I'm going to call it isValid ISBN 10. Open parenthesis, close parenthesis, hit enter, and I've now got my function established. Now, this thing returns a value. Functions return a value. This returns a value. And so here's how I establish the return value in the function. In many languages, the way you do it, you come down here and you say return some value. I want to return hello. I would say return hello. That's not how I do it in VBA. And I'll admit the way we do it in VBA is a little bit weird. Instead of saying return, I set the name of the function equal to the value I want it to return. So in this case, the name of the function is isValidISBN10. And I will say isValidISBN10 equals hello. And so now I can call that from somewhere. I can call that from a worksheet. I can come here and say isValidISBN10, open parenthesis, close parenthesis, enter. And it's thinking about it. It shouldn't think that long. Oh, I don't want a question mark. I want an equal sign. Sorry. It's not thinking about it. It's just printing that. Well, there we go. So I've got an equal sign. Question marks for the immediate window. Of course, equal sign. Okay, so that's it. I've created a function. We call this sometimes a user-defined function. I can use it in a worksheet, and it just returns whatever I've told it to return. Anywhere that I could put any expression now, I can put this function. I can come to the immediate window and put a question mark and say isValidISBN10, and it just returns hello. So what I mean by it returns its value to where it was called from, I can take the call to the function, get rid of it, and put the return value in there, and it will behave exactly the same. So it just goes and does what it does. The value it takes back would go in place of where the call to the function was made. Question? So the question is, this is just workbook specific, and the answer is this should be available to any open workbook. So let me come over here to my other workbook that I had and call it from here, equals isValidISBN10. And that I may be wrong about that. Yeah, maybe it is just for this workbook. So is there a way to make it so anytime I open this instance of Excel to have it, these should be already public. I don't know the answer to that. My guess is no, but I'm not sure.
Well, I'm just thinking along the lines. We talked about where we can store these
functions, subprocedures, yeah.
Well, the code that we wrote, have like the my work.
The personal macro workbook. Yeah, the question is, what if we just put it in the personal macro workbook? And the answer is, if I can't reference it from another open workbook, I won't be able to reference it from the personal macro workbook either. So it sounds like this is limited to this workbook. Yep. So here, I mean, if I type in hello, I'm saying print hello. But the whole idea is that I'm just showing that it gets kind of how it processes the return value. So I'll type isValidISBN10. And so what really happens is I want to think about that as saying, whatever value comes back from this function, I'm just going to imagine putting that return value right in the place where the function was, and then the rest of the line can continue. So in other words, I could have more than just that value. I could say, hello, master. It's the way I like my computer to talk to me. And it would then, it has to evaluate isValidISBN10 first, and then it's going to concatenate that with master and then print the result. Just as if I had written hello in quotes and master here, it would evaluate. So the function gets evaluated, the return value comes right back to where the function was, and then the larger expression is evaluated.
To answer the earlier question, save it as a LAN.
Oh yeah, so if we, good point. So if I wanted to make it available more broadly, I could probably make it into an add-in and then install the add-in. I've never tried that with a function. Have you tried it with a function? Yeah, so our TA has tried it with a function, and that works. So it turns out we'll cover how to make add-ins in this class. It's a breeze. You want to do it right now? It takes less than 30 seconds. Are you ready? You've got your workbook with everything defined in it. You say File, Save As. You got to give it a place to save. I guess that's fine. And Save As Type. Here you're going to find Excel add-in. It's one of these choices. right here. You save it, and then it's an add-in. You then install it the way you would install any other add-in, and you're ready to go. All right. Okay. Functions can take a type. So when I'm defining a function, like when I define a variable, I give it a data type. Since functions return a value, they can have a data type as well. What's this thing going to return? And the way I declare it is the same way I declare the data type for a variable. So right after I've declared the variable or the function, I'm going to come here and say as and give it a data type. And so what makes sense for this function is valid ISBN? What type should I return? String, not going to be a string. Think about the name of the function. Is valid ISBN. True or false, so it's going to be a Boolean. So I'll say Boolean here. So the idea is I want to give it an ISBN, a candidate ISBN to look at, and I want this to tell me true if it's valid, false if it's not valid. Not so bad. So instead of saying is valid ISBN equals hello, let's say is valid ISBN equals true. And so now, if I run this, I will find out that I'm the true master. That's pretty good. The point is, it will return whatever you tell it to return. And I'm going to try to make it return hello now. I guess it's going to give me an error. You know, hello, the type mismatch. Hello is not true or false. You can't return hello. I can return true. What's not true? False is not true. That's true. Okay. Getting this thing set up is I got to get some way to be able to figure out what to operate on. How is it going to know what to evaluate? And the answer is we've got to give it a value to operate on. So we've got to set up the function to be able to receive that value. You've been wondering since our very first day what these two parentheses were for. The suspense is over. It's for setting up a variable to receive that value. So I'll come right here, and so I'll just call it the candidate. Candidate as, better call it a string. We are declaring a variable right here. Dim candidate as string. This is a declaration of a variable. I could have more than one, but by separating with commas and having another declaration statement in here. It turns out that the only thing that I can do inside the parentheses is declare a variable. And so I don't need to put the keyword dim. Not only do I not need to put it there, I can't put it there. But it is a declaration of a variable. It's a special variable called a parameter. But it's a variable. It is a location in memory that's got a name that I use to refer to that location in memory. But because I declared inside those parentheses, it takes on a little bit different behavior. And that is, it takes its value when the function is called. And so now I'm passing in this value here. It is going to be accepted into the candidate variable, special variable called a parameter. And while this is running, let me just go ahead and debug that. Debug.print the value passed in is candidate. This, it should print back the value passed in is candidate, or sorry, is 1, 2, 3, 4, 5, 6, 7, 8, 9, X, and then true master. All right. Someone help me understand the difference between this line and this line. Those got printed by two very different mechanisms. Do you see what they are, what the difference is? Here is printed by this debug print while the function's running. What causes this one to print? Yeah, this question mark is saying, hey, we're trying to print whatever this gets evaluated to. On the way to figuring out what this gets evaluated to, it prints this line. And then once it's done, it puts all this back together, and then it prints this line. So that's why this one prints first, and then this one. Questions? If I come over here to my call from my worksheet now, if I just try to refresh this, we're going to have an error because we're not sending it a value. It's requiring a value. But if I come in and give it a value, what's it going to print? What will it print now into this cell when I hit enter? Yeah, there's three options. It's either going to print true, it's going to print true master, or it's going to print the value passed is this, or it's going to print all that. There's 4 choices. It's a great multiple choice test. And the answer is it's going to print only the return value of the function, so it should just put true. Right? The master part got added on here. That's separate from the call to the function. And this is just what happens while the function's running. In fact, you can see that it printed it again. It actually printed it right here. How are we doing, folks? At this point, I'm hoping that you're looking at this going, okay, I think I'm following this. How many of you are saying, yeah, that's me? I think I'm following this. How many of you are going, I totally get this? And how many of you are going, this is something like witchcraft. How does this work? There's a few of us in that situation too. All right. Hopefully by the end of the day, you'll feel a little more comfortable with it. So the idea is that when I cause this function to be executed, in this case, I'm causing it to be executed by telling it to print this whole expression. The interpreter says, I got to go run this function. It does whatever it does. We establish the value that it returns. That comes back to where the call was made, and we move on. Okay? All right. So let's go ahead and do something meaningful with this. So let's start to validate our 10-digit ISBN. So what's the first thing we should probably check? If this is a 10-digit ISBN, is that a question? So the question is, can we go through why this is returning true? And the answer is, yeah, I can take you right through that. So here, inside this cell, we're saying this cell equals the result of this function, call this function. For Excel to figure out what this function evaluates to, it has to invoke the VBA code that's identified by, the name here is valid ISBN. And it's passing this value ASD, ASDF. So the Excel then says, okay, I've got a function over here called isValidISBN10. The value that got passed in is that collection of characters, ASD, ASDF. That's going to put the value AS, ASDF in the location in memory with the nickname candidate. So now we're going to print the value passed in equals candidate. I'm sorry, not the equals candidate. The candidate will be evaluated. And so it will print the value passed in is and the value that's in candidate. And then here we're saying that this function is going to equal true. Here's how I establish the return value, by setting the name of the function equal to the value I want it to return. So Excel now knows, oh, when I pass in, Excel doesn't really have any idea what happens on the inside of this. It just says, when I call this function and pass in ASASDF, it returns true. And it goes, great. Then Excel takes that value true and then displays it here on the worksheet. Oh, at this point, the only thing this function can return is false. I'm sorry, the only thing it can return is, but it's true that it can only return false. The only thing that it can return is true. No matter what you put in, it's going to be true. We've got to add some logic to decide, is it true or not? And right now, I mean, was that a valid ISBN? That's not a valid 10-digit ISBN, so we're not there yet. We've got some work to do. Fortunately, we've got almost an hour.
So I thought the top part doesn't look like any of that stuff in your actual code down below.
Okay, you're talking about here, the immediate window?
Yeah.
And you said that this part was just for, it is, just for while I'm developing, I want to check something out. That's absolutely right.
So I don't see any of those values.
You don't see any of which values? Here, down here in the module. So yeah, this should be determining what happens in the Excel. Hey, Nathan, you want to come take a look at what he's doing? This should be determining what shows up in this. It should have nothing to do with this. It should all be determined by what we have here. Nathan will come take a look and see what you've got. All right. So we're going to verify that we got to decide, is this thing a valid ISBN? Is it a valid ISBN or not? So if it's a 10-digit ISBN, what's the first thing we should check for? You just put in check 10 digits. Listen, if you send me 9 digits, what's the likelihood that it's a valid 10-digit ISBN? 0. Don't even have to go through the calculation. If it's not 10 digits, it can't be valid. So our very first thing that we're going to do is we'll come in here and we'll say if the length of the candidate is different than 10, then exit function. Ooh, that seems like I should do more than just exit. What value is this function going to return if I don't tell it to return anything? I'll give you some choices. It'll return a 0-length string. It'll return 0. It'll return true. It'll return false. What do you think? False is correct. It's going to return, if I don't ever change the value, it's going to return the default value for the data type. Data type is Boolean. All data types have a default value. The default value for Boolean is false. So if I never tell it to be true, it's going to return false. So here's what I'm saying. Listen, if the length of the candidate is different from 10, then get me out of here. There's no reason to look anymore. And because I've never set it to true, it's going to return false. All right, what else can I check? And before I start calculating that algorithm, what are some other things I could check? Okay, so do we have numbers or something other than numbers? Now, it's a little more complicated to look at the check digit than everything else because the first 9 have to be numeric. But that last one could be number, or it could be an X, it could be capital X, lowercase x, I don't know. So let's deal with the check digit first. So let's do this. Let's check to see if that last character is in a small set of valid characters. There's only 11 of them. Well, 12, I guess, if you count upper and lowercase x. I got 12 characters it could be. Let me just check and see if this character is in that set. Full credit for class participation if you can tell me the function, the string function that lets me look at a string of characters and tell if another character is inside that function. Covered it in chapter 8 or 9 or something. Go ahead. Yeah, instring, INSTR. Is that the one you had? You had another one. What was it? Yeah, so find would probably, I don't think that's in VBA. I think that's a function in Excel. So, but instring is the one in VBA. So let's take a look. INSTR, open parenthesis. And then the first thing I give is I say, okay, there's going to be a string I'm going to look in, but before I even tell it the string I'm looking in, I got to tell it where do I want to start looking in that string. And the answer is I want to start at the very beginning. So 1, first character, and then the string that I want to look in. And the string I want to look in is right here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Little x, big X. That's the set of characters, the set of valid possible characters for my last digit. If the last digit is not one of those, it's not a valid ISBN. So now I just need to tell it to look for the last digit. So the first string is, or the first argument is, where do I start looking? The next one is a string, what am I looking in? And now what am I looking for? So, full credit for class participation if you can tell me what I'm looking for. How do I get that last character? What function will let me get it? Go ahead. Right. Right, so I'm using the right function, and I'm looking at the value that's being passed in, candidate, and then the rightmost one character from candidate. So my instring function, opening in parenthesis, start at the first place, look in this string, look for this string, close parenthesis, and that is going to return the position of where it finds the second string argument inside the first string argument. If it doesn't find it, what will it return? 0. If it returns a 0, then it didn't find it. And so I want to say if this returns 0, that means it didn't find it. If it didn't find it, it's not a valid ISBN. Get me out of here. So at this point, I've figured out the length is right if I've made it past this one. If I make it past this one, I've figured out the check digit's a valid check digit. So now all I have to know is, are the other 9 digits a number? Turns out there's a pretty good function for that. If the leftmost of candidate, 9 characters, the leftmost 9 characters of candidate, I just want to know if that's a number. Well, there's a function called isNumeric. Question mark isNumeric. I give it a string, and it tells me if it can figure out what number that is. And it says, yeah, that's a number. I can figure that out. 44.5, that's a number. 44.A, can't figure it out. That's not a number. Here's one that you might not quite know. How about just dot by itself? I mean, that's a valid number, and it's a valid character in a number. Is it numeric? What do you think? Not a number. Dot's not a number. How about 1 dot? Is that a number? Yeah, that's a number. 1.0. It's a number. I got it. And so I'm going to ask if the leftmost 9 characters is numeric. I think it should be are numeric, but the function's called isNumeric. So now I'm asking isNumeric, passing it these values. This returns true or false. So if it is numeric, that's good. I don't want to get out if it's numeric, so I better do something to reverse this. So if this equals false, then exit do. Exit function. So now if I made it here, if we made it here, we have the right length, check that it's valid, and the first 9 are numeric. Now I think I'm ready to start working on that algorithm. As it turns out, if I try to start calculating that algorithm before I've done these initial checks, I could be in trouble, because I'm going to assume that I've got 9 characters to work with. What's going to happen if they only passed in 7? I'm going to try to look at the 8th character, and Excel's going to go, there's no 8th character, and it's going to have an error. So it's pretty important up front to say, let me do these simple checks first, and then once I know I've got it well formed to this point, I can check to see how the algorithm clears. We ready to do it? So let's go ahead and do something that allows us to start figuring this part out. So I've got to take the first character, multiply it by 10. Add the result of that to the second character multiplied by 9. Add the result of that to the third character multiplied by 8. So ultimately, I want to get this into a loop. But I'm going to begin this by actually writing those statements out so I can see the first few of them and see what's the same and what changes as I go from statement to statement. So I'm going to declare a variable up here called checksum. No, let's do this. Let's call it step 1 as an integer. So this is my first step. First step is add all these guys up. So step 1 equals, I got to get the first character off of this. So how do I get the first character? Any thoughts? The left of candidate, one character, times 10. Is that right? Yeah. All right. Now, that's getting me started. Let's look at the kind of the next step. So I'll say step 1 equals what it used to be plus, all right, now I got to get the second character times 8. How do I get the second character? Full credit for class participation if you can give me the second character. Anyone still need full credit? We're kind of early in this semester for you to all have full credit. Go ahead, give it a shot. The mid candidate start at 2 and length of how many? Length of 1. Right, and I'll take that number and multiply it by 9. Now, order of operations, multiplication is going to happen before addition, so I don't need to put parentheses around this. Wouldn't hurt to do it, but don't need it. Okay, so that gets me the next one. Now, this is going to be pretty easy from here because now I want the third character multiplied by 8. And then I want the fourth character multiplied by 7. We see the pattern? We'll do one more. Fifth character multiplied by 6. And don't get too happy typing. We're going to erase all of this. So we're doing this here just so we can see the pattern. So once I get past that first row, once I get past that first action, the rest of this is really almost exactly the same. I've got a vector of numbers changing here and a vector of numbers changing here. Question is, could I modify this one so that it fits the same pattern? If I can, that will be great. What do I do to modify this so it fits the same pattern? Well, can I say that step 1 equals step 1 plus this first valuation? Will this work? What value does step 1 begin with? It's a numeric variable. I declared it as an integer. Its initial value will be 0. And so I'm going to say step 1 is going to take on a new value. It's going to be 0 plus, has that changed this? Has it changed this at all? Hasn't changed it. 0 is the additive identity. I can add it to anything that doesn't change the value. I'm in good shape. So now the question is, can I make this left, can I do this left something like I did the mid? And the answer is yeah. I can make mid behave just like a left. All I have to do is say start at the first character, take one character. And so now I've even made that first statement look exactly like the rest of them. Questions? Did someone say it's time to save? It is time to save. Okay, so let me put this in my downloads. And I will call it ISBN 10 Winter 16B. And it'll be an XLSM. Okay, so now I'm ready to introduce a loop. The only thing different between these lines is I've got this number that goes from 1 and up, this number that goes from 10 and down. So I'm going to use a loop now that we have really wanted to use before, but we haven't introduced it. And today we introduce it. So this is going to be the for loop. And to do the for loop, I need a control variable. So let me dim x as an integer. And now here's the syntax for the for loop. For x, some numeric variable, equals 1, 2, 9. Next. What this loop will do now, it'll execute 9 times. So, but in addition, it's going to change the value of x as it goes. So the first time I hit this line, it goes, I'm starting a for next loop. And it goes x equals 1. It sets x to 1. And it says, okay, I'm going to keep running until x is bigger than 9. Great. And so it'll run this loop once. And this time, the value for x will be 9. In fact, I'm going to go ahead and execute this. I'm going to put a breakpoint so I can step through this. Call it from here. getting ready to enter this loop. Right now, x is 0. I haven't entered the loop yet. And now I'll step. Now it's made x1, so it should print 1. Next, we'll change the value of x, and we'll add 1 to it. Back to the top, and it prints 2. And so the loop is changing the value of x for me automatically. It should go as long as x is not bigger than 9. So here, now x is 9. That's a valid value for x. I'm staying in the loop. I'm printing 9. I hit the next. What does next do? 2 things. Next increments my control variable, and it sends me back to the top. It incremented the control variable, went back and looked up here and said, uh-oh, x is bigger than 9. And so I'm no longer in the valid boundary. I got to get out of here. In fact, if I print x now, what's it going to print? It prints 10. It actually incremented x, made it 1 bigger than it was the last time, 9. It takes a look at this and says, yeah, I'm out of bounds, and it lets me out of the loop. There's a question here? Okay, go ahead. The question is the only thing you can do is increment by 1, and the answer is no. If I want to increment by some other number, all I have to do is come here and say step 2. So the step says how much do I add each time I hit the next. So now if I were to run this, it should print 135. 13579, because each time it got to the bottom, it added 2 to it. I can even count backwards if I want to. I can step -1, in which case I would have to say from 9 to 1. So I would have to reverse the order of those. Okay, so now I've got this value x that's counting up from 1 to 9. So all I want to do is take one of these lines and put it on the inside of my loop. So the first modification is pretty easy. Here's where I'm incrementing, counting up 1 through 9. So all I do is I replace the analogous position in that statement with x. But it's counting the wrong way for this one. This one's got to go from 10 down. Well, I could create another variable, start at x, subtract 1 off of it each time I'm in the loop, but there's a simpler way. Yeah, I could just change this expression, x, this expression 10, to be 11 minus x. I do have to put this in parentheses, otherwise the multiplication with the 11 would happen first. I've got to make sure that that happens together. That makes me a 10, and then I can multiply this through. And so now that will execute all those times, and it will add up that value. And I should be able to now, at the end of this, say debug.print step 1. And if I've passed in 1, 2, 3, 4, 5, 6, 7, 8, 9, x, then step 1 should tell me 210. What's this other one? I'm going to go ahead and bring this one in as well. So when I execute that one, it should give me one value. When I execute this one, it should give me a different value. But each one should be predictable. So here's the Stice Brothers ISBN. Okay, so this one should print 210 along the way, and it'll print true because I haven't really changed it from printing true. Is valid ISBN. Did I get something wrong here? Oh. Don't need any master here. Uh-oh, subver function not defined. What have I missed? Step through this. I'm not sure why I was getting subver function not defined. Am I still saying the value passed in? Oh, right here. Thank you. Let's get rid of this one. One, 2, 3, 4, 5, 6, 7, 8, 9, x. Uh-oh, I'm getting 114. Oh, I've got step 2. That's what you're saying. Step 2 is the problem. Yeah, I'll just leave it as step 1. So 114 is not the answer I'm looking for. 211 isn't the answer I'm looking for. Uh-oh, what have I missed here? Someone go to print step 1. I'm expecting to see expecting to see 210. Well, this is a little bit embarrassing. Let me go ahead and print x as well as 11 minus x. Let me see, I'm getting the set of values that I'm expecting to see. 110, 29, 110, 29. That all looks good. All the way down to 9 and 2, 9 and 2. How am I getting 211? Step 1 isn't affecting it. Shouldn't be. If you can see my mistake, it's definitely full credit for class participation. Nathan, help me out here. What have I got wrong? Okay, time to start working on the interim values. So let me just see how it looks on the inside of each one of these. Do I have the right, maybe I don't have the right values in here. 1, 2, 3, 4, 5, 6, 7. Aha. 7, 8, 9. That looks better. Let me get the intermediate step out. There we go, 210. Debug doc, whoops. There we go, 210. You see, the order is important. That's the whole thing that we're trying to figure out. Did we get the order right? So I've got step 1 calculated. So far, so good. Questions? All right. Step 2 says take that value and divide it by 11 and take the remainder. So I'm going to go ahead and declare step 2. And I'll declare step 3 while I'm at it. Okay, so I've got step 1 going on. Let me go ahead now and say that step 2 is equal to remainder mod 11. So step 1, yes, mod 11. That step was pretty easy. Print step 2. I'll go ahead and run that. It should print me 210, and then whatever the result is here, the remainder of that is 1, so it should print me 210 and then 1. Again, with a separate function not defined. Debug.print step 1, step 2. That looks perfect to me. Wow. What's that? Yeah, mod is the remainder. So mod is take this number, divide it by 11, whatever the remainder is, assign that over here. Next step is take 11 minus the result from step 2. So step 3 is 11 minus step 2. And now that tells me the remainder is 10. Is that what I'm supposed to get? Yeah, the remainder is 10. Step 4 is, hey, if it's 10, then it's x. Otherwise, it's just whatever it is. So far, so good. I think I've written this algorithm to where I'm ready to take a look at the answers. Shall we then? All right. So there's 2 conditions that I have to take a look at to see if the check digit is true. Let's take the easy one first. If the rightmost value of my so I mean if my check digit is equal to what I calculated, So the rightmost value of my candidate is equal to what I calculated. That might be a problem when I go to look at the x. So let's deal with that one first. So let's look at if it's an x. So if step 3 is equal to x, trouble is it could be uppercase or lowercase. So what function can I use to force it down to lowercase? Oh, yeah, thank you. If step 3 is equal to 10. Thank you. If step 3 is equal to 10, and the rightmost character of my candidate is equal to x. That's what I'm after. Thank you. Trouble is, it could be uppercase or lowercase. So I could say, and the rightmost character is equal to lowercase x, or the rightmost character is equal to uppercase x, or I could force that rightmost character to be lowercase. How do I do it? What function does it? Lower would be the function in Excel. It's a different one in VBA. Lcase. So I'm going to wrap lcase around this whole thing. Lcase that so what does it mean if this is the case? If step 3 is 10 and the last character is x, what does that mean? Means something. What does it mean? Yeah, it means that's a valid ISBN. We calculated 10, you gave us x, that's a valid ISBN. So just assign it to be true. Now, we're going to pay a little more attention to the else if clause on Wednesday, but let's take a peek at it now. Else if, one word, step 3 is equal to our check digit, the rightmost character of our candidate. If those two are equal, also true. Otherwise, is there any other condition that could be true for this? No. So if it's not that, it's going to be false. So the only time we're going to come in here and set it to true is if we've made it all the way down to here, we've calculated a 10 and we got an x, or whatever we calculated is what we got in that last value. Otherwise, we're going to return false. In fact, we don't even need this last clause. We could skip that because it's going to be false if we don't hit one of those trues. That doesn't hurt to leave it in there. So now this should return accurately whether it's a valid ISBN. So that's true. If I change the check digit to something else, it should return false. If I leave the check digit and change anything else, it should return false. So let's change this 6 to a 5. That's false. If I transpose the 5 and the 6, still false. I could change one number here and one number somewhere else and come up with a true. But any two sequential numbers transposed, it's going to tell me it can't do it. So that's pretty good. Let's just take a look at calling that from inside of a worksheet. So here's my worksheet. Let me go ahead and put in, let's do it over here. Let's put it right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, x. And then let's pass, instead of passing the string in, let's pass the reference to that cell. That returns true. That's pretty good. Let me go ahead and pull in the value from the Stice Brothers book. And I'll put the Stice Brothers book again. We'll modify a couple of these. I'll change their check digit to a 5. And I'll change my first number to a 2. Copy that formula down. And the first two should be true. The next two should be false. So we have successfully implemented the ISBN 10-digit check digit algorithm. Whew. And we still have like 2 minutes to spare. Anything else I want to, oh, there's one more thing I want to cover here. And that is, while I'm debugging this, can I just run this? Can I just click on play? The answer is no. It says, hey, you can't, well, what do you want to play? I just click play. What do you want to play? Well, I want to play the function. Why won't it let me play the function? Yeah, it's not because it's a function. If it was a function, I can play functions as long as they don't take an argument. If they take an argument, I've got to, before to be able to run them, I've got to give them a value. So I can't just play it. So here's what I like to do. I'll make a sub-procedure called a_test me. It's a sub-procedure. I call it a_ because that's going to make it alphabetically really small. It's going to be like the first one that shows up in my list of sub-procedures. And then I will put inside that a call to a test with a test value. Debug.print is.isbn. So now when I'm here and I press F5, it's going to say, what do you want to play? And it will have highlighted the one that I want to play because it's the first one. It highlights the first one. So now I can execute that and it will run and I'll get to see the output. So I'm here, press F5, ready to hit enter, and it executes. I also cannot just step into this. So if I'm used to debugging by coming up here and say debug step into, no can do. So if I want to debug it, I better put a breakpoint at the very first line of executable code, press F5 and hit enter, and that'll let me debug. That's going to do it for today.